Up to here, we have met and used these results. Probabilities of mutually exclusive outcomes are OR cases, and we add the probability values of those events. Probabilities of independent events are N cases. Then we multiply the probability values of those events. Some problems require using both of these principles together. Tree diagrams are one way of doing this. A tree diagram is simply a way of representing a sequence of events. Tree diagram records all possible outcomes in a clear and uncomplicated way. Let's take a look at a simple example. Example 14. Fred is trying to guess the last two answers to a multiple choice test. For each question, there is a probability of 0.2 that he is able to guess the answer correctly. Complete a tree diagram to show the possible outcomes to Fred's guesses. Tree diagrams, we use branches to identify the outcomes, and we use the numbers on top of the branches for the probability values of that outcome. So here we are given a drawn tree diagram, but it is incomplete. We are going to complete the probability values. At the beginning, in this question, we have two options: answering correctly or incorrectly the questions. And guessing answers correctly has a probability value 0.2. This is a given information. Therefore, guessing incorrectly has a probability value 0.8. So this branch has a value 0.8. For each pair of branches, so these are pairs here in the tree diagram, we have a sum of 1. So the first set of branches, these are the first set, shows the probability of guessing correctly or incorrectly the first answer. The second set of branches, these are the second set of branches, shows the probability of guessing the second answer correctly or incorrectly. There is no change in guessing correctly. It has value 0.2, so I'm going to write 0.2 in the places of branches which has correct outcome at the end, and here 0.2. So each pair must be 1, so 0.8 goes for the incorrect guessing. So we finish completing the tree diagram. Part B. Work out the probability that Fred guesses the correct answer to both questions. So we are looking for the giving answers both correct. So probability of correct and correct. So let's use the tree diagram. For the first question, follow the path. For the first question, I reach correct. Then, after guessing the first question correctly, I continue to guess another correct answer. So I follow this path. So these are the connected branches. And since these are independent events, we can apply multiplication rule. So the connected branches in the tree diagrams, you're going to multiply the probability values to get 0.04 as an answer. Part C. Work out the probability that Fred guesses one answer correctly and one incorrectly. So we are looking for a correct and incorrect together, and order may change. So let's look at the tree diagram. We have For the first answer we have, let's follow with an orange color, we have a correct answer, then followed by an incorrect one. So this is a desired outcome. Another may be guessing the first one incorrect, followed by a correct answer. The second one as correct answer. This is another desired outcome. So we need to first calculate the connected branches, my multiplication, and then add the desired outcomes together to find the final answer. So in part C, we are looking for probability of correct and incorrect together, or it may be probability of first incorrect and then a correct answer. So each one is the multiplication of 0.2 and 0.8, but in the opposite order. That doesn't change their answer. The answer is 0.16, and both of them is the desired values of the outcomes. So I'm going to add both to have 0.32. This is the answer of part C.